Hi everyone. This is a look at molecular polarity. This is different from bond polarity. Bond polarity had us using electronegativities and doing a little bit of subtraction to classify individual bonds. This is about the whole molecule all at once. It's all about symmetry. And there's only two categories, polar and nonpolar. If the molecule has bilateral symmetry, that means the top and bottom are the same, and at the same time, the left and right hand sides are the same. If it's symmetrical in those two different ways at the same time, we have a non-polar molecule. In contrast, an asymmetrical molecule is polar. If there's a difference between the two sides or a difference between the top and bottom, we have a polar molecule. This is a little bit difficult because sometimes people have a natural tendency to link asymmetrical and nonpolar together, and that is not correct. Here it is symmetrical and it goes with nonpolar. Asymmetrical, not symmetrical, goes with polar. Polar means two differences. Think about the Earth. The Earth has poles, a North Pole and a South Pole. They're really different. The North Pole is an ocean. The South Pole is a continent. The North Pole has Santa. The South Pole doesn't. The North Pole has polar bears. The South Pole doesn't. The South Pole has penguins. The North Pole doesn't. It's all those differences. If there's two different sides, like the North and South Poles of the planet, if there's differences, asymmetrical means polar. If it is symmetrical, then we're talking about nonpolar. The good news is we can just use structural diagrams. We don't need 3D stereochemical shapes. A structural diagram is going to do the key. It's going to be enough, with the exception of heads up, be careful, watch out for V-shape. V-shaped is always polar. So if you can recognize a V-shape, water is a polar molecule. Otherwise, we just need to draw the structural diagram. We don't need lone pairs, we don't need the 3D shape. Now we want to see, are the left and right hand sides the same? And how about the top and bottom? So here I go. Here's methane CH4. I visualize a line down the center. Are the left and right hand sides identical? Yes. At the same time, are the top and bottom identical? Yes. I need those two. The top and bottom are the same, and the left and right hand sides are the same. I got that answer twice. This is a symmetrical molecule. It is non-polar. How about ammonia, NH3? I don't need the 3D shape. Structural diagram is enough. How about the left and right hand sides? They are the same. But what about the top and the bottom? Not. The top and bottom are not the same. We have an asymmetry. It is polar. Symmetrical, nonpolar, asymmetrical, polar. And I hope that helps.